Okay, we're here at Southern Illinois University. We're doing an all-wheel drive large roll Autodyne installation, and this is our second trip out. Ken Romero came out the first trip and installed the rolls into the pit. You can see that they're in place. Now we got to finish the mechanical installation, and then we'll do the electrical connections and the computer setup. You can see we've got a large case over here with our tools in it. We've got various panels, boxes, sitting around, a couple toolboxes over there. Customer's got a fairly nice facility, large fans to move air through the pit, large air handling capability for air for the vehicle, and exhaust extraction hose. Very, very nicely done, with sound deadening panels on the walls, which will acoustically make the room more easy to live with. We've got quite a job ahead of us. We got 3 days here, 2 of us doing the job to try to complete the installation. Then we come back next week and we'll do the training. See, we have various panels in place. It's quite a extensive undertaking. Hopefully it will show some video later today. It's about 9 o'clock in the morning right now. Hopefully by about 5 this afternoon you'll see a mostly assembled dynamometer. Okay, it's about 12:30. We've been here for 4 hours, and what we've decided we had to do was these arms for the hydraulic. We had to put them in place temporarily, put the drive shaft on. We don't have all the bolts tight on it yet. We just snugged them because we needed to know how far to move this thing. And you can see our V-rails are pretty much flush, and then if we extend this all the way out, we get pretty much flush on the other side as well. Right now you can see we've got about 12 to 14 inches sticking out. The real challenge is going to be getting this pallet jack out of here. We are going to have to jack the dyno up, put the feet down, move those rails. We've got them marked on the cement. Then we have to turn the pallet jack sideways to get it out of there. Then we put the V-rails back in place, and we're going to have to crawl underneath there and slowly lower those feet until the dyno sits down on the V-rails. There's no other way without a forklift. But we're waiting on shims. We can't do any of this until we get the shim stock that we need to jack this thing up. We've got 4 Grizzly blowers over here we've unpacked. We've got our sensor box hooked up, and we have tested the forward and reverse motion. We also tested the eddy current and its functioning. We ran our umbilical cord, which is much too short. That's all the farther they're going to be able to pull this sensor box out. We've got a large amount of accessories over here. We've unpacked calibration arm. We plumbed in the air hose. We've temporarily put all our wires on down here so that we could test some things. But you have to do everything twice on this because you've got to be able to test it first, then get it positioned, and then you've got to put the thing back up on the jack and then drop it back down before you tie everything in. We've unpacked most of our box of stuff. We got a whole mess of trash over here, and this is as far as we've made it in four hours. So hopefully by this evening we'll have it positioned, leveled, and probably put covers over the rolls and get some of the other stuff going. Here's some pretty cool things from Monoxavent. They're stands, and they have the collectors on them so you can hook up your exhaust hose and capture the exhaust. And they're adjustable, and they can go up and down, pivot, and the whole deal. Highly recommended. Okay, so we got some 1/2 inch thick shim stock that we're going to lay underneath the V-rails, and then put our other shim stock on top of those, and then set our chassis back down on that. We've got to jack this thing up fairly high in order to get it to work right, get it level with the floor. So in order to do all this, we're going to have to jack this thing up, and in order to do that you have to take these struts off. And what Ken found out about the strut bolts is that there are different length bolts, and so he's got those all adjusted. So these big long bolts here, when you go to put them in, you're going to have to make sure you get the right lengths. The longer ones, I think, go through this part. So, alright, we got the pallet jack out of there, but you can see we only got one rail in. So what's holding this thing up, it's all cocked, is we got the foot right here jacked way up, so we could get that pallet jack out of there and we can get the rail back in there. So we got to put the rail back in, the shims back in, get it all lined up. Then we'll start screwing down the foot to get it back down on the rail. It's just really not made for working with a pallet jack in there. This is really designed to have some sort of forklift where you can just drive over here, lift up a corner, and then move it back down in there. Doing it with a pallet jack is a lot more work than it's cut out for. But we're getting it. Alright, so we've got the rail repositioned, and I've lowered this corner leg. Now Ken's got to lower that corner leg. It takes a 15/16 or 7/8 wrench, which we don't have. So we're working on it with a crescent wrench. And eventually it'll drop down, we hope. Alright, so we're tightening up these 1 1/8 bolts, which we don't carry wrenches for, and they're nylocks. And what we notice is that these are too short to catch the nylock, really, and these, as you can see down there, are plenty long. They all should be the same length. These bolts here are actually shorter. So we're mounting these platform supports. You can see that one's in there in the position it's supposed to be. And then this one, you put this support arm on here. You go to bolt this front support on, the foot's going to be in the sump hole. So obviously our drawing is wrong if the customer built this pit the way our drawing's supposed to be. So now we're going to have to figure out how we're going to support the front leg here, since we got a big hole in this thing. Okay, we got this front platform ready to drop in there. You do have to remember to put the bolts in that direction, because when the dyno comes forward, if you have the bolt heads or the threads sticking out, you're going to run into them and you'll lose about an inch or two of your movement. This cross beam here, we figured out, is going to go across the bottom of these two legs, and then this cross beam here goes across the top, so there'll be two supports for that. We're going to have to get cement blocks and put into this sump to create a spot for our foot to sit on. We've got to drill holes through those pieces of flat steel there, and then put anchor bolts into the cement there to keep our rails from moving back and forth. We won't probably do the front side, we may. But at this point we just got to anchor them so they can't slide. We found that moving the roll set forward and backwards, there's enough friction that it can push the rails. So we're going to anchor those rails, we're going to have to. And then this front panel, the front edge of it has to be tack welded to the steel that's in the top edge of the sump or the pit. So we'll do that tomorrow as well. That's our progress for the day. Our second day of drilling. Okay, we got the center part all done. You can see what we had to do down there. We had to stack bricks and shims, but it's all locked in there good. It ain't going nowhere. And we got all the cables tie wrapped in. See them all over there. A lot of extra length on the cabling. That should probably be changed. And then got this one tied in. Everything moves like it's supposed to. There was an extra rail cross rail that would go in the bottom, but the problem is if you put it into the bottom, the hoses on the hydraulic system, when it's all the way retracted like this, the hose would hit the rail. So we chose not to put the rail in. It isn't going to hurt the stability of this thing at all. But and there wasn't bolts sent for that rail, so maybe, and it doesn't show up in the drawing either. So it's very possible that the rail isn't supposed to be used. So it's just excess from out here. I took it out here and put it on a pallet. This rail right here. So as far as we know, it wasn't in the drawing. It would have fit down there, but it interferes with the hydraulic lines, so we decided not to put it in. So this piece has to be welded, so we're in there knocking out cement and grinding off paint so we can weld to that part of the pit. We use the 2x4s and the roll set just to hold it in place. Okay, we got one bolt each in the front V-rails. That's all we're going to put in there. We're done drilling. Those V-rails can't move. We've got this panel over here on. This panel's been welded. Notice I can't move it. And we had to notch this panel right here. We got the screws in, the countersunk screws just barely in, so we can do some beating and adjusting if we need to. So we're going to put the other panel on, see where that gets us. Alright, it's the end of the second day, and we tried to put all the covers on. We tried an experiment with this big flat cover here and the one on the end. We thought, let's try putting them underneath and just see if it would work, because if you put them underneath, then the center panel would be able to be taken off without removing those big long panels. Well, you can't do that, because then they'll warp up and it just doesn't work. We tried it. So we did those two panels twice. They have to go on top, and unfortunately what that means is in order to get that center panel off to calibrate the load cell, you got to pull both these panels off. So it just sucks. What really needs to be done is a center cover plate needs to be put on those center panels for calibration, or hell, just cut some holes in there. Same over here, although this end all you got to do is just take out all the screws and then the center panel will come up out of there. But the front one, it's just a poor design. You cannot get access to the center or to the front load cell to calibrate it without taking these two big long panels off, and those mothers are heavy. Well, anyway, we have a functional working frame anyway. We'll cinch down all the bolts tomorrow and calibrate it, and that'll get us to a point where we can start doing some of this other electronic setup. So, alright, the system is done for our 3 days on site. We have the chassis all complete. You can see here where Ken put this cover on top, and we shimmed underneath it so that these long covers are shimmed so that they don't bow in, and this cover being on top means you can just take it off when you need to do cal, so it makes it a lot easier. The boards for the ramps, we put them on. We did drive a car on here and we cracked every one of them, so I don't know that those are the best solution, and I never can figure out if I got them on there in the right direction or not. Somebody who designed them should put arrows on them so that we know, which way they go. We have the sensor box configured, and it's got a lot of stuff on it. Power supply for the two AFM 1000s, USB to DB9 converter for the 5-gas cable, and again, as always, the 4 connectors that aren't being used tied off. Cabling, we had to buy the USB port expander for the number of USB ports we need. We've got all the ones in the back being used, 4 of them there, and 3 more here, so that's 7 USB ports. That leaves the 2 in the front open so you can use them for something. Second USB to serial port adapter so that we can connect to the AutoLogic. We did test all the voltage ports. We calibrated the widebands. Their 2 sensors are hanging there. Power strip mounted. Need a power source for the trip light, for the B&B adapter inside, and for the sensor box. Computer system set up over here. Cabling all tucked away. Power strip added to it. We got 1, 2, 3, 4, 5 items plugged in there. AutoLogic case sitting here. Inside the sensor box, the AutoLogic and B&B components are mounted. As you can see on the top, we had to cut a hole as usual, and we now have the B&B device mounted inside. You can see how I zip tied the power connection, and I also carved out the plastic around that connection to make sure it makes good connection, and it worked perfectly this time. Lessons learned from last time. Jumper wire added between R85 and R79. Serial number 236. We reconfigured the LCDs on the front. We're using SAE power here, a couple of thermocouples here, oil pressure, barrel pressure, one of the wide bands, wheel speed. Apparently they've asked for a 50-foot umbilical cord so we can extend this box further out. That'll mean we'll have to cut some zip ties and reroute the umbilical cord. Notice how the umbilical cord is tied in and stress relieved. Here are all the extra components. We attempted to put a car on and strap it down, but their eye bolts that go in these T-bars cannot be secured. They won't tighten up, so we gave up on it. We'll do it when we come back. Alright, bolts that we're missing. One button head here. Second button head. Third button head. Fourth button head. Fifth button head. So we're missing 5 button heads and 1 countersunk bolt. So we have to remember to get that. 5 button heads, 1 countersunk. 6 button heads. 6 button heads, 1 countersunk. Okay, we're going to call it a week.